Now, some people say that artificial intelligence might eventually be more intelligent than normal human intelligence. Is that something that you subscribe to?
I think that that's likely to happen in the future. It hasn't happened yet. The kind of AI that we see in common application today tends to be narrow and domain-specific or very task-specific. And if people are interested in seeing some of these applications, they can look at the website of the AAAI, and in particular an innovative applications of AI conference that is sponsored by the American Association for Artificial Intelligence. And there we've documented probably 400 plus successful applications of narrow AI in a wide variety of fields and addressing a wide variety of tasks.
Now, is artificial intelligence or intelligence of any kind basically about processing larger amounts of information faster, or is there another component to it that cannot be replicated by a machine?
Well, let's see. Human intelligence is not just about processing information fast. In fact, we're not really fast information processors today compared with the speed of machines. The advantage that machines have today includes speed, but eventually we'll see that it will include a wide variety of strategies that people don't use and perhaps new capabilities that people don't have today.
Can machines exercise judgment? A machine might be able to figure out how to achieve a goal given a set of resources, but can it set the goal? Can it decide what goal is worth achieving?
Well, machines today are able to set limited sub-goals for solving larger problems. They do this frequently in a process called backward chaining. They set sub-goals for larger problems that they're addressing. But in the sense that you're asking the question, to address it squarely, currently machines are addressing the problems that we want them to address. I suspect that in the future they will pose new problems and address those problems.
Where does the name Singularity University come from? What is meant by a singularity?
It's a term that's pulled from physics and originally referred to the event horizon of a black hole, where it's very difficult to see beyond that event horizon. And in this case, the event horizon is the advent of very advanced technologies, such as strong AI, or AI that is at human levels or beyond, significantly beyond, perhaps. And when you have those technologies coupled with nanotechnology in its advanced form of molecular manufacturing, which will do for humanity's relationship with molecules and matter what the computer did for our relationship with bits and information. It will basically blow the roof off of our ability to manipulate matter. And when that happens, coupled with ultra-intelligent machines, we achieve a kind of event horizon beyond which it's difficult to predict precisely what will happen.
Blowing the roof off of something always has sort of a funny connotation. Like, you're never really sure that that's really what you want to happen. It seems like rapid change could introduce a lot of instability. So in our rush to advance technology, are we also considering possible instability and other negative fallout and making sure that we have contingencies for dealing with that?
Right. So the answer to that squarely is yes. We do talk about that at Singularity University often and deeply. There's no question that technology can have both harmful effects and positive effects. I personally am an optimist, and I think that technology has had primarily positive effects and a lot of negative effects, and I think they need to be addressed squarely with other technologies, not just more technology, but better technology. And by better, I mean technologies that are designed to work with nature effectively and technologies that are designed to have minimum negative fallout.
Is singularity itself part of a larger network? So, for example, if somebody in the government who's in charge of solving climate problems needs to find an expert on the topic, they say, well, who do we know who's an expert on this? Let's go to Singularity University. Has it reached that level of visibility where it's considered a valuable resource?
Well, we certainly have had government agencies come by and do workshops with us and do brainstorming sessions with us. And they've been great, really fun.
Now, you're located on the grounds of NASA's Ames Research Center. You rent space from them. Are there any ties between Singularity University and NASA Ames, aside from the fact that you rent space there?
Right. They're not just our landlords. They're our sponsors. They are actively engaged. We have lecturers from NASA Ames come in, and also other NASA campuses come in and give lectures to the students. We have students working on problems that are relevant to the space program. I think that there's a very deep synergy there, where these accelerating exponential technologies have a lot of implications and possibilities for next generation space travel.
Is the space program considered an important part of solving problems? In other words, if we can't solve the world's problems, maybe we'll just leave and go someplace else.
I don't think that that's the idea. In fact, I think that what I've seen at NASA is that they have a very deep commitment to solving the Earth's problems. And in fact, many of the climate change models were built from satellite data that, that came out of the space program launching satellites.
Is there an underlying philosophy to Singularity University, or some kind of worldview that could be summed up in a few words?
Well, I don't think that there's a single worldview from the Singularity University faculty. We have a very heterogeneous faculty. I do think that we have some values in common. One of those values is that we all are convinced that these accelerating exponential technologies are going to have a very big impact on our world, and that people are not sufficiently aware of them and really haven't thought about the implications in a deep way. Another value is that we think that these technologies can help us address humanity's grand challenge problems for a very specific reason. The problems themselves are accelerating, and the problems themselves are massive in scale. And that's just the kind of problem that these technologies can address.
Okay. I'm getting the signal that we're almost out of time. I'm getting a little confused by the signals I'm seeing. 30 seconds. Oh, we have 30 seconds left? Yeah. That's not very much time, is it? Okay. Anyway, I guess we are going to have to wrap the show now. I have lots more questions I could ask you, but we'll have to discuss it offline somewhere.
I'd be happy to.
I do appreciate your coming in, discussing these issues. It's a topic that is dealing with important issues that I think we all want to know more about and get a handle on. I'd like to thank my guest, Neil Jacobstein, for being here today, and thank you for watching. Be sure to tune in next time for the next episode of Future Talk, and please visit our website, www.futuretalk.net. I'm Martin Wasserman. We'll see you again next time.